Scientists continually revise and create models based on new data or evidence, changing our understanding of how the world works. Ernest Rutherford, also known as the father of nuclear physics, has majorly changed our view of the world over and over again. One of Rutherford's major contributions was to our understanding of the structure of the atom through a series of experiments, which would famously become the gold foil experiments. Ernest Rutherford was born on August 30th, 1871 in Brightwater, New Zealand, where he received a quality primary education before growing up and eventually attending Canterbury College. In 1895, Rutherford moved to Cambridge and worked with Professor J.J. Thomson, who was famous for his discovery of the electron and his plum pudding model of the atom. It was at Cambridge that Rutherford discovered that alpha and beta particles were the emissions that came from radioactive atoms. This research with radioactive materials became Rutherford's life's work. Rutherford arrived at the University of Manchester in 1907, having been named Langworthy Professor of Physics. He was still thinking about his recent research on the decay of atoms, but his attention had shifted to the emitted particles themselves and what they could reveal about the nature of the atom. Working alongside Hans Geiger, Rutherford sought to establish a better understanding of these particles. In 1908, Rutherford was trying to measure the charge-to-mass ratio of alpha particles. To do this, he and Geiger created a device that was able to count the alpha particles. However, the device proved inaccurate because the alpha particles were too strongly deflected by the air molecules within the detection chamber. Rutherford was puzzled, as he believed the alpha particles were too heavy to be scattered so greatly. This led Rutherford to question how much matter was needed to scatter the alpha rays, and he set Geiger and an undergraduate student, Ernest Marsden, on the problem, leading to the set of experiments eventually known as the gold foil experiments. The main experiment consisted of aiming a beam of alpha particles at a sheet coated in zinc sulfide, with a thin metal sheet placed in between. When an alpha particle impacted the zinc sulfide, a brief flash of light was produced. This allowed the physicists to track the number and location of any alpha particles passing through the metal sheet. According to the plum pudding model, when directed at the metal sheet, the alpha particles should pass through with little alteration in their trajectory, as there was nothing in the atom strong enough to influence them. This is not what happened in the gold foil experiment. While the majority of alpha particles passed cleanly through the sheet, a large amount were scattered in every conceivable direction, including back at the source. In one fell swoop, the gold foil experiment disproved the plum pudding model. A new model had to be devised, one that accounted for the behavior of the alpha particles. In 1911, after much testing and rigorous experimentation, Rutherford published his revised model of the atom. In his model, Rutherford speculated that the vast majority of an atom's mass was concentrated in a central particle in the atom. This central particle had a positive charge equal and opposite in sign to the electrons that revolved in the space around it. This condensed center of mass was what the irregular alpha particles were deflecting off of, but because of its minuscule size, the majority of the particles never came in contact with it. This central particle would later become to be known as the nucleus. Rutherford's model helped establish the idea of the nucleus, and the idea that atoms are made up of even smaller particles. However, while the model greatly increased our understanding of the atom structure, like any model, it was not perfect. A few years after its conception, it was replaced by the Bohr model, which used the idea of electron orbits to better explain the behavior of electrons around the nucleus. Bohr's model itself proved to be inaccurate for atoms other than hydrogen, and it in turn was replaced by the quantum mechanical model, which illustrates the position of electrons in an atom as a cloud around the nucleus in specific orbitals. These advanced models of the atom would not be possible without Rutherford's interpretation of the gold foil experiment. Once again, science is constantly progressing. Only time will tell if even better models of the atom are to come.